Hello, here is my video on partial fractions that is for mostly my A2 MAS groups. The reason why I'm going to do it, it's not quite the next thing in the specification, but it's very much related to the algebraic simplifications that we've been doing. In that, it's like a reversal of some of the simplifications. It's like doing some of the simplifications in reverse. It still involves rational functions, but what we're doing is instead of adding together two fractions to get one single fraction, we're separating one single fraction into two, into a sum, into partial fractions. So I will send you this sheet. This is the partial fraction sheet. I'm going to look in this video at how to do question 1 and possibly question 2, but it is the same method. What you're presented with here in question 1 is x minus 2 all over x plus 1 times x minus 1. Now notice that that is like an answer to some of the questions that we've had recently where we have a single fraction with two factors on the bottom. Now what we're going to do is go the reverse direction and separate that out into the two fractions that we'd add to give it. Now how do we do that? So here it is again. I've written it out. The first thing to do is write the form or the template of the answer. Given that our denominator is x plus 1 times x minus 1, it's going to come from some sum of the form a over x plus 1 plus b over x minus 1, because sums like that will give us the right denominator. And so we go to that right hand side and we do what we would do if we had that sum, a over x plus 1 plus b over x minus 1, well, we take the common denominator that we expect and that we want to see and that we start with. And it's x plus 1 times x minus 1. The a then needs to be multiplied by the x minus 1. And the b, when we move over to it, needs to be multiplied by the x plus 1. Just in the way we were adding fractions in class and in lessons recently. Of course, that still doesn't tell us the a and the b. We still need to think a bit more about it, but that's what we ultimately want to find, is the a and the b. So we've got our original expression, the single fraction, is equal to that single fraction involving a's and b's, but they have the same denominator. So we just need to worry about equating the numerators, which I have written there. X minus 2 is a times x minus 1 plus b times x plus 1. Now, in order to work out the a and the b, if we choose x's to substitute in carefully, we can simplify the expression. If I let x equal minus 1 right across that expression, the x minus 2 becomes minus 3. And notice on the other side, the term involving b will cancel out or go to 0. And it leaves me with minus 2a. So minus 3 equals minus 2a allows me to work out that the a is 3 over 2. And similarly, if I choose a sensible different value for x, I can cancel out the a term in the top line. If I let my x equal 1, the equation becomes minus 1 equals 2b. And the a term cancels out. And that allows me to work out that the b is minus a half. So if I put those into that form, which is what I started with, that is letting the a equal 3 over 2 and letting the b equal minus a half, then I get my answer. And my partial fractions can be written like that. Okay, example 2 on the sheet is similar, But we start with 2x minus 1 over x minus 1 times x minus 7. And again, the important thing is we write it in the type of form that we expect to get the answer. In other words, sums of that form, a over x minus 1 plus b over x minus 7. We don't know the a and the b yet, but we will find them. But its sums of that form will give us single fractions like that, where the denominator is x minus 1 times x minus 7. So go through the same thing. If we were adding those two fractions together in terms of a and b, and using the methods we've looked at, we would get a times x minus 7 plus b times x minus 1 all over the denominator that matches up with what we start with, which is x minus 1 times x minus 7. And because the denominators match, we just need to equate numerators, which means 2x minus 1 equated with a times x minus 7 plus b times x minus 1. And again, our job is to work out the a and the b. And the sensible thing to do is look for sensible x's to substitute in that will cancel out terms and simplify. So if I let x equal 1, this term here becomes 0. And overall, I'm left with 1 equals minus 6a, which allows me to say that a is minus a sixth. If I let x equal 7, it will cancel out the a term and leaves me with 13 equals 6b, which allows me to say that b is 13 sixths. So then if I go back to what I started with and substitute those values in for a and b, I can write my partial fractions like that. 13 over 6 times x minus 7 minus 1 over 6 times x minus 1.